All right, welcome to Unit 4 on equations and inequalities. I'm going to be a little speedy with this first section here. If we take a look at your learning goals, we have 27 through 37. And essentially we're going to be looking at solving two-step equations and also multi-step inequalities as well, which means that you have a negative or a less than or greater than symbol rather than an equal sign. And we'll graph those as well. Our first learning goal is 27, and so let's go ahead and plug that in. This is just the concept that you'll be able to determine if a value is a solution or not to an equation. And so let's go ahead and take a look at that. Before we do, you can see all of your definitions. You have quite a bit, but look how they're separated into the addition properties, division properties, multiplication properties, and subtraction properties. So different rules that allow us to do different things when we're dealing with equations. Okay. All right. And so let's go ahead and move to this first part. We're just going to talk about the top and then move ahead a little bit because we're going to be doing a lot of checks as we go. So the big things I want you to see is we have equivalent expressions where we have two expressions that are set equal to each other, and we can substitute any value for x and it will remain true. I especially know this because of the commutative property. 2x plus 4 I know is the same as 4 plus 2x no matter what is in 4x. And so anything I plug into there is going to show true to be equal. So if I input a 2 into x here, I can see that 2 times 2 is 4, and this ends up being 4, and so we are equivalent. I could change to any number I want, and that's still going to remain true. Now, there are other situations like these non-equivalent expressions. So you have two types. Sometimes only one value for x works, and others don't. So when we're just testing things out, a lot of times we could just put something simple in like 1. Okay, I don't have space below, so I'm going to go above here. So 2 times 1 is 2, plus 4, 3 minus 2, and I end up with 1 equals 6. And so that's not equal to. But I do want you to see that if I inputted something different, so let's say that I go ahead and input a 6 into here. 2 times 6 is 12, plus 4, 3 times 6 is 18, minus 2. These ones end up working. So this is an example where sometimes an equation only has one value that can be put in for a variable to make it true. All right, our other scenario is this, okay? And this is where you end up with no solution because nothing will work at all, anything you try, okay? And I know that to be true because, and this is sort of a preview of what we're going to be getting into, I want to get x by itself. So I want you to just sort of follow along with this and see. So to get rid of a minus 7, I'm going to add 7 to both sides. And so I end up getting x plus 11 equals x, okay, because this is a 0 pair. Now, I want x by itself, so to do that, I would have to get rid of this x. So I have a positive 1x, so I can subtract 1x to both sides. But you can see that when I do that, it makes x disappear entirely. And I can't just have 11 equals blank, okay, or even just 11 equals 0. If x disappears entirely, that means nothing, there's no value that works for x, and so there is no solution for this, okay? So I want you to see an example of all three of those. We're going to go ahead and cross these out and move on, only because we're going to be doing a lot of checks as we continue. So let's jump right to our one-step equations with addition and subtraction. Now I want you to picture a little chicken, and that chicken only has one wing. Okay, so you can imagine, I can't really draw a chicken that great. You can imagine if that chicken tried to fly, it would fall over one direction. So we really do need to have two wings. Whatever you do to one side has to happen on the other to make it balanced. Okay. All right. So our goal to solve an equation is to get the variable alone or by itself. Okay. Another sort of fancy term is isolate the variable, if you want to get that language in your head. All right. So what is the inverse operation for addition? So we've always talked about inverse operations. Opposite of addition is subtraction. Opposite of subtraction is addition. Okay. In 7th grade now, we want to be thinking about the additive inverse, or adding the opposite. Okay. And so when we look at a 7, if I have a positive 7, the additive inverse, or adding the opposite, would be subtracting a 7. And so actually, let's go ahead and put these as coefficients. Okay. And we'll go ahead and plus x. So these aren't coefficients. They're just a term with x. But I want you to be able to visually see what we would see. So here's a term plus x. So I have a positive 7. So to get rid of that and make a 0 pair, I'm going to subtract 7, and I'm left with 1x. Okay. Right here, I have a negative 21. So the additive inverse is add 21, or positive 21. That creates a 0 pair, and I'm left with x. Over here, instead of having a positive 2/3, I'm going to subtract 2/3, and I end up with x because we created that 0 pair. I have a negative 1/8, and so I'm going to add 1/8, create a 0 pair, I end up with x. Here I have a negative 3.25. The additive inverse to create that 0 pair is plus 3.25, and I end up with x. So that's essentially what we're doing. So let's go ahead and jump into it. This is the process that you have to have, so make sure you imitate this exactly. You're going to draw a line down to separate the two sides. Always look for the variable and see what is with it. So I see a negative 9, so I'm going to add 9 to both sides. Notice I do it right underneath. That creates a 0 pair, and so I left with t equals 9, positive 9 and negative 8 is a 1. Now we want to check it every time. I know this is a little bit annoying, but you need to do it because we're setting up foundational routines for more difficult math later in algebra, algebra 2, and so on. And so you need to write this exactly, substitute for t. So I put in my 1 minus 9 equals negative 8. And I can see that negative 8 equals negative 8, so I'm good. Okay, on to number 2. Separate my two expressions on each side. I see my variable is r. What's with it is a negative 5. To get rid of that, I'm going to add 5 to both sides. Okay, that creates a 0 pair, and I have r equals 14. We're going to do the check by plugging in and substituting for r. So we have plus 14 equals 9, and 14 minus 5, keep the sign of the bigger digit, 9 equals 9, check. All right, number 3. Right away, I'm going to KFC this. So I see my variable on this side, separate my workspace. I have a positive 17. To create the 0 pair, we're going to subtract 17 to both sides. Okay. Once we do that, we create a 0 pair, so we have x equals, and then we have the negative 22 and the negative 17 is our negative 39. Okay. Let's go ahead and do the check to see. So we're going to substitute for x in order. So negative 39 plus 17 equals negative 22. And when I do that, 39 minus 17 keep the sign of the bigger, I do get negative 22 equals negative 22, and that checks out. All right, let's take a look over here. I look at the variable, and I see that we have a positive 1/5 next to it. So I'm going to subtract 1/5 from both sides. Okay, I have a negative 2/5 and a negative 1/5, which gives me a negative 3/5. Okay, we're going to go ahead and do our check. We have negative 3/5 plus a 1/5 equals a negative 2/5. And I always write that in the numerator, the negative symbol. All right, and then we end up with negative 2/5 equals negative 2/5. So that did check out. All right, let's look at 5 and 6. If you want to even pause and try them on your own and then check, you can do that. I'm going to KFC real quick. So I see with my x, I have a negative 1/4. So to create the 0 pair, I'm going to add a 1/4 to both sides, creating my workspace. Okay. Right away, I see that I don't have common denominators, so I'm going to go ahead and have to create that. So I actually have 2/4 that I'm adding. And so we have 3/8, 2/8. And so we have 3/8 plus 2/8. And so our x equals 5/8. So let's go ahead and do our check. So I'm going to fill out our 5/8 for x plus a negative, instead of 1/4, I'm going to create the equivalent fraction right now. So negative 2/8, that way I can check it more easily, equals 3/8, and then we can see that 3/8 equals 3/8, and we're good. All right, and last one. I'm going to KFC this right away. I'm also going to, just to uncomplicate things, create an improper fraction. So we end up with a negative 6/5 here instead. Okay, so I have x plus negative 6/5. I want to get rid of the negative 6/5, so I'm going to add 6/5 to both sides. Let's separate our workspace. Add 6/5. I'm left with x on this side alone, and I have a positive 6/5 with a negative 2/5. So that puts us at 4/5 for x. Let's go ahead and do our check by substituting. So I have 4/5 for x plus negative 6/5 equals negative 2/5. And I can see that when I do that, different sign subtract, I get negative 2/5 equals negative 2/5. And that all checks out, and that is your first lesson.